We have a user table, so now we need a registration form that writes into it. Building forms by hand, reading each field of the request, validating it, and guarding against cross-site request forgery is tedious and easy to get wrong, so we want a library to handle it for us. In the Flask world, that library is Flask-WTF. It takes care of form fields, validation, and CSRF protection. But there's a catch, and it's the important lesson of this section. Flask-WTF is built around Flask's synchronous request object, so it simply does not work inside an async Quart app. And that's the takeaway to hold on to. In an async application, you can't reach for a synchronous library and expect it to work. If a package wasn't written for async, if there's no Quart-flavored version of it, that's usually a sign you shouldn't be using it in a Quart app at all. Happily, there is a Quart-flavored version here. It's called quart-wtforms, and it brings WT-forms to Quart the async way, giving us validation and CSRF protection for free. So we'll use it and let it do the heavy lifting. Let's add it. Just like every package, we declare it with uv-add, no sync, so it gets installed when Docker rebuilds the image. We're storing passwords, so we also need a way to hash them. We'll use passlib, a well-tested password hashing library. Add it the same way. Since we added packages, rebuild the web image so they land inside the container. WT-forms and its CSRF protection need a secret key to sign tokens, and we already have a secret key from the counter boilerplate. We just need to switch CSRF on, open quart-env, and add a flag for it. And write it into your settings. Open settings py and add this line. We read it as a string and compare it to 1, so the value ends up as a real boolean. We default it to on, and later in our tests, we'll flip it off so we don't have to deal with tokens there. Now the form itself. Create a forms.py file inside the user folder. We import two field types, a string field for the username and a password field for the password, plus two validators. Then we import QuartForm, the async base class our form inherits from. Our UserForm defines just two fields. The username is required and limited to 15 characters, matching our database column, and we ask the browser not to autocomplete it. The password is also required. Notice how declarative this is. We describe the fields and their rules once, and the library handles rendering, reading the values, and validating them. That same user form will drive both registration here and login in the next lesson. Before we write the view, we need templates to render. We'll start with a base layout that every page extends. Create a templates folder at the project root and add base.html. We'll build it in two parts, starting with the document head. This is a standard HTML shell. In the head, we pull in Bootstrap's CSS from their CDN, so our pages look decent without us writing much styling, and we define a title block each page can fill in. Now let's add the body. In the body, we have a container with a content block, which is where each page's real content will go. At the bottom, we load Bootstrap's JavaScript and leave a scripts block for pages that need their own JavaScript later, like our live feed. Every page needs a navigation bar, so let's create navbar.html in the same templates folder. For now, it just links to login and register. This is Bootstrap's navbar component with our brand name and two links. Notice we build the link targets with URL4 rather than hard-coding paths. That's a best practice. If a route ever changes, the links follow automatically. WT-forms can render fields for us, but we want each one wrapped in Bootstrap markup, with its validation error shown. Rather than repeat that markup for every field, we will write a small Jinja macro in a new template called form helpers. A Jinja macro is like a reusable function for templates. This one takes a form field and renders its label, the input itself, and if the field failed validation, a red list of the error messages. We will call render field for every field so our forms stay consistent and short. Now the registration page. Create a user folder inside templates and add register.html. We extend base.html, set the title, and drop the navbar at the top of the content block. Then we center a column on the page and show an error alert if the view passed one in. We import our render field macro and use it for the username and password, so both come out as nicely styled bootstrap fields. Then we submit the form with a button. The one line worth pausing on is the form's CSRF token. That renders a hidden field holding the CSRF token, and this single line is our entire cross-site request forgery protection. The library generated the token, put it in the form, and will verify it when the form comes back. Done by hand, cross-site request forgery protection is fiddly and easy to get subtly wrong. Here, it's one line. Now we can write the real registration view. Open user views, py, and rebuild it. Starting with the imports we'll lean on the most. From typing we bring in optional and union for our type hints. From passlib we bring in pbkdf2shia256, the hashing scheme we'll use. And from Quart we import the usual helpers plus flash, which lets us stash a one-time message for the next page. Now the rest of the imports plus the blueprint. Now the register function itself. Our root accepts both get and post. We start by creating the form with await UserForm create form. Because reading the incoming request is asynchronous in Quart, building the form is an awaitable, so we await it. The heart of it is await form, validate on submit. On a get this is false, so we skip straight to rendering the empty form. On a post, it checks the CSRF token and runs our validators, and only returns true if everything passed. That one call replaces all the manual request method checks and field validation we'd otherwise have to write ourselves. Inside, we grab our database engine from current app dbc, exactly as we did in the counter app, and open a transaction. First, we select any user with the same username. If we find one, we set an error, because usernames must be unique. If the name is free, we hash the password with pbkdf2. This turns the plain password into a long, scrambled string that we store instead of the real thing. Even we can't reverse it, which is the whole point. If our database ever leaks, the passwords are useless. Then we insert the new user with the hashed password. If there were no errors, we flash a success message and redirect to the login page, which we'll build next. Otherwise, we fall through and re-render the form with the error shown. Before we try this out, there's one loose end. Our register view redirects to login when a sign-up succeeds, and our navbar links to it too, but we haven't built that route yet, so the page would crash if we loaded it now. So exactly like we did with register earlier, let's add a placeholder login route just below it for now. We'll build the real login page in the next lesson. Let's try it. Bring up the stack and rebuild so the new packages are in place. Head to the register page. Submit the form empty and you'll see the required field errors, courtesy of our validators. Now register a real username and password. The app hashes the password, saves the user, and redirects you to the login page. Try registering that same username again, and you'll get our user already exists message. And just like that, QuartFeed has its first real users, passwords hashed, and accounts saved. But signing up is only half the story. Those users still can't get back in. That's next. We'll log them in, give them a session, and let them log out.